So your next unit 4, that is forced vibration. When the body vibrates under the influence of external forces, then the body is said to be under forced vibration. The example is ringing of electricity bell and vibration of the air compressor. So types of external excitation, three types of external forces applied are periodic force, impulsive type forces, random forces. The amplitude of the forced vibration is given by h equal to f naught divided by square root of s minus m omega square whole square plus c into omega square into sin omega t minus psi. So the maximum amplitude of forced vibration f naught divided by square root of s minus m omega square whole square plus c into omega square. So r is nothing but frequency ratio, that is omega divided by omega n. The amplitude of the forced vibration is given by, this is the equation. The phase angle is pi equal to tan inverse of 2 into c into r divided by 1 minus r square. So magnification factor or dynamic magnifier, the ratio of the maximum displacement of the forced vibration to the static deflection due to the static force, and is denoted by the magnification factor, that is mf equal to x max divided by x naught. That is magnification factor equal to 1 divided by square root of 1 minus r square whole square plus 2 c zeta r square. It is clear that the magnification factor depends upon the ratio of the circular frequency and the damping factor. So this is the frequency ratio curve, the curve between the magnification factor and frequency ratio. Okay, this is known as the frequency response curve. The next one is the phase frequency response curve. The curve drawn between the phase angle and the frequency ratio is known as the phase frequency response curve. Disturbance caused by the unbalance. So almost in all rotating and reciprocating machinery like an electric motor or turbine or IC engine, the amount of unbalanced force left in even after the correcting the unbalance on precision balancing machine, this unbalance produces the existing force in the machine. So amplitude of force vibration is given by SA. Okay, this is the amplitude of force vibration, so we already discussed here. So next we have to find out the transmissibility. The transmissibility is a measure of effectiveness of the vibrating isolating material. There's the types of the transmissibility. One is the force transmissibility, another one is the motion transmissibility. The force transmissibility is defined as the ratio of the force transmitted to the force applied on the system. This ratio is also known as isolating factor. So this is the force transmissibility, the force transmitted to the foundation divided by the force applied on the system. The motion transmissibility defined as the ratio of the absolute amplitude of the masses to the base excitation amplitude. This ratio is also known as the amplitude transmissibility. Next one is vibration isolation. The process of reducing the vibration of the machine and then reducing the transmitted force to the foundation using vibration isolating material is called as the vibration isolation. The material used for the vibration isolations are rubber, cork and metallic springs. So next one, the types of isolation. Isolation of the forces. Vibration produced an unbalanced machine should be isolated from the foundation so that adjoining structure is not set into the vibration. This type of isolation is known as the force vibration. Next one is the isolation of motions. The unbalanced machines are isolated from their foundation so that there should not be any damages either to the machine or the foundation. This type of isolation is known as the motion isolation. Okay, so this is the types of vibrations.